In this video, I'd like to talk about the math question of the day for February 12th, 2023. And with this problem, we have a polynomial that we need to factor by the grouping method. And to solve a problem like this, you need to have a solid understanding of basic factoring techniques, but also the factoring techniques of polynomials, which are usually taught in Algebra 2. So at this point, go ahead and pause the video, spend a couple minutes trying to work through this on your own, and when you're ready, we can go through this together. Now, assuming that you have attempted this problem, we can start going through it together. And if you do have suggestions for any future videos, feel free to leave a comment down below. Now, we do know this is a polynomial since all of these terms with the variable x, these are raised to integer powers, and it's a sixth degree polynomial since the highest power is 6. Though it's not written in standard form. In standard form, we would actually write it in reverse with the highest power first and then counting down in order. But with factoring polynomials, when the degree of the polynomial is bigger than 2, they tend to be fairly difficult. Now, for a second degree polynomial, let's say something like this, sometimes you can factor it, sometimes you can't through, let's say, simpler methods, but we can always find the factors of this using what's known as the quadratic formula. If we have a cubic expression, there is a cubic formula, though it is very tedious and difficult to use. Same for the quartic polynomial, but in general, students are not taught those methods. They might be shown them in high school, but those are more advanced methods. So when dealing with polynomials with degree of 3, 4, 5, 6 or higher, we need to come up with alternate strategies. And the simple truth is that once the degree is bigger than 2, these are difficult to factor. And one of the only techniques we have for dealing with these high power polynomials is the grouping method. And the general idea with grouping is that we're going to pick 2 of these, pair them together, and then pair the remaining 2 together and see if we can factor anything out. So for instance, let's look at these 2 terms, and I'm choosing these 2 because they each have a 7 in them, and we can factor that 7 out. They also each have 1x in common. This has 3, but this only has 1, so we can factor out 1x from both of these, and we can factor out a 7 from both of these, so that here we're left with a 1, and here we're left with x squared. Now, with these next 2, we can group them together as well since they are only x's. This has 4 multiplied together and this has 6. So they share 4 in common, and we can pull out 4 x's so that this just becomes a 1 and this becomes x squared. And remember with factoring that you can always check your work by redistributing and making sure that you get back what you started with. But the key idea with this grouping method is that for this to work, when we pair them together and then pull out what's known as the greatest common factor, I often refer to this as just simple factoring. What's the biggest number that divides evenly into both of the terms or all of the terms? Then once we pair them together and pull out the greatest common factor from each, if we are left with the exact same expression in parentheses, then this grouping method will work. Since now, in some sense, we could imagine this as 7x, let's say, times a plus x to the 4th times a, where a is just this 1 plus x squared. But rewriting it like this makes it a little bit clearer that both of these terms share a common factor of a, which we can then factor out, so that here we have 7x, and here we have x to the 4th. But of course, we know a is this expression here. But the general idea is that when looking at this polynomial after applying the grouping method, they share this expression in common, which we can factor out. If we factor out this 1 plus x squared, we are just dividing by 1 plus x squared, which means we'll just be left with a 7x here. And when we pull it out of this term here, we again are pulling out the 1 plus x squared. We're dividing by 1 plus x squared, so we'd just be left with x to the 4th. And this would be our factored polynomial. And if we want, we can check this by redistributing, just using the FOIL method. or the distribution method when you think about it generally. Now, if we wanted, we could continue factoring this, since looking at this expression here, each of these share a common factor of x. So we can pull that out. We get x times by 1 plus x squared, and then all this is multiplied by 7 plus x to the third. And we could actually keep going, since this right here is a sum of two squares. And this is something that you probably won't need to actually answer this problem, since this is typically taught in algebra rather than in a more advanced class. But if you do want to factor a sum of squares, you need complex numbers, and that's typically something you might see in a pre-calculus class. But if you do want to see it, this would factor as 1 minus I times x multiplied by 1 plus I times x, where I, we know, is the square root of minus 1. This is the imaginary unit. And this right here, we can just leave as 7 plus x cubed. And I should mention that this right here is technically a sum of two cubes. We can rewrite 7 as the cube root of 7 cubed, so that these cancel out and we just get back 7. But rewriting like this, it's clearer to see that this is a number raised to the third power. You just need to manipulate it a little bit to be able to see that. And we have two cubed numbers added together, and there is a formula for that, factoring. And if you do want to use that technique, I encourage you to look up the formula for a sum of two cubes and apply that factoring. But I won't do that here, since we will end up with a lot of cubed roots, which again are quite messy. So I will leave it as 7 plus x cubed. And again, for a normal algebra class, this solution right here is perfectly valid, but if you want to go that extra step further, this will work as well. And the general method to check everything is just to multiply everything back out and see if you get back what you started with, which of course can be a little bit tedious, but if you want to be confident that you did it correctly, that is the general approach.